What if I told you that time, the thing you feel ticking every second of your life, might not actually exist? Not in the way you think. Physicists have spent over a century trying to explain what time is, and the more they dig, the stranger it gets. Because here is the uncomfortable truth. Our best theories of the universe disagree about time completely, and some of them suggest it isn't fundamental at all. We all feel time moving forward. You were born, you were watching this video, and eventually you'll die. In that exact order, it seems obvious, but physics has never been able to explain why time moves in one direction, or even what it really is. Here is the crisis. We have two great theories of reality. Einstein's general relativity, which describes gravity and the motion of planets and galaxies, and quantum mechanics, which governs atoms and particles. Both theories use time, but they treat it in completely incompatible ways. Relativity says time is elastic. It bends, it stretches, it slows near massive objects. Quantum mechanics just assumes time exists. It doesn't explain it. It uses it like a clock, sitting outside the theory. When physicists try to merge these two frameworks into one, a so-called theory of everything, time often vanishes from the equations entirely. The universe looks frozen. No change, no flow, just a static mathematical object. That is the problem of time. And it is one of the deepest unsolved puzzles in all of science. The usual explanation for why time has a direction involves something called entropy, a measure of disorder. The second law of thermodynamics says disorder always increases. A glass falls and shatters. It never unshatters. That irreversibility is what gives time its arrow past to future. But this explanation has a giant hole in it. The fundamental equations of quantum physics work equally well forwards and backwards. There is nothing in the math that prefers a direction. The arrow of time only appears when you zoom out to large numbers of particles. And it raises an even bigger question. Why did the universe start in such a perfectly ordered, low entropy state to begin with? That is statistically almost impossible. Entropy is a clue, but it is not the full answer. Here is where things get genuinely mind-bending. Over the past few decades, physicists have started treating information, not matter, not energy, as the most fundamental ingredient in the universe. And it started with a very strange problem involving black holes. Stephen Hawking showed that black holes slowly evaporate, leaking radiation. But that raised a terrifying question. What happens to the information about everything that fell in? Quantum mechanics is absolute on one thing. Information cannot be destroyed, ever. If black holes destroy information, the entire foundation of quantum physics crumbles. Resolving this forced physicists into a radical idea. Information isn't just abstract bookkeeping, it is physical. Erasing it costs energy. Storing it requires real physical resources. And here is the kicker. It may be more fundamental than space and time themselves. A new framework is emerging, one where space-time isn't a smooth, passive stage on which events play out, but a kind of memory, a recording medium, made of discrete microscopic elements, each with a finite capacity to store quantum information from every interaction that passes through them. Think of it like a crystal that stores defects from its past. Space-time in this picture isn't perfectly smooth the way Einstein imagined. It is granular, and every particle collision, every quantum interaction writes an entry into its memory permanently. Here is the key insight. Once information has spread out into the surrounding environment, once it has been written into space-time, you can never fully get it back. Not because of some external rule, but because you'd have to undo every physical consequence of every event that followed. That is not just hard, it is physically impossible. And that is why time has a direction, not because of special initial conditions, not because of statistical arguments, but because the universe is constantly writing information into itself. And that record only ever grows. Earlier states have fewer records. Later states have more. Time is the accumulation of what has happened. This isn't just a philosophical reframe. It makes real predictions. Take dark matter, the mysterious invisible substance that astronomers invoke to explain why galaxies spin faster than they should. In this information framework, you might not need dark matter at all. Regions of space-time that have recorded more interactions, more history, carry a heavier informational memory. That memory effectively boosts gravity. Galaxies spin faster not because of invisible mass, but because the space-time they move through remembers more. Black holes become natural test cases too. As matter falls toward a black hole, information imprinting accelerates. Time keeps advancing locally because information keeps being written. When the black hole evaporates, the outgoing radiation should carry subtle signatures of that history. It is not perfectly random. It is shaped by everything the black hole ever recorded. And in quantum computers, right now in labs, researchers are running experiments where even fully reversible quantum equations generate an effective arrow of time through how information spreads. Time's arrow emerging in a controlled lab environment. So what is time? Really, it is not a river flowing. It is not a background parameter sitting outside physics. It is not even a fundamental feature of reality. Time may be something the universe generates from within, from the irreversible act of physical interactions, writing information into existence. The universe doesn't just exist in time. Time is something the universe continuously writes into itself. And that means every moment you experience, every memory, every heartbeat, every second that passes isn't just happening in time. It is time. You are literally made of the universe's accumulated record of itself. If that doesn't keep you up at night, I don't know what will. Drop a comment. Do you think time is real, or is it something we invented to make sense of change? And if your mind just got stretched in a direction it didn't expect, subscribe. We've got a lot more of this coming.